Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which I go through all the Pythagoras and trigonometry that you need to know for your upcoming test. So we're going to start off by going through Pythagoras. So Pythagoras was just the dude's name, and he had a theory concerning right-angled triangles. Remember, of course, a triangle can only have one right angle. So, for a right-angled triangle, we call the longest side a special name the hypotenuse. It may not always look like it, but the longest side, the hypotenuse, is always the side opposite the right angle, so they're facing each other. So Pythagoras' theorem was if we call the shorter sides A and B and we call the hypotenuse C, then we have the rule that A squared plus B squared equals C squared. That is Pythagoras' theorem. And what it means is that if we know the lengths of two sides of a right-angled triangle, we can use this theorem to find the third side. So just to make things a little quicker, it might be easier if we rearrange this formula. So I can just take the square root of both sides of the formula in green, and I get this C equals square root of A squared plus B squared. So that's the formula you use if you want to find the longest side. You just type that straight in your calculator, it'll give you the answer. So if I want to find one of the shorter sides, I can rearrange this formula. Let's say I call it A. So if I rearrange this formula and make A the subject, I get A equals the square root of C squared minus B squared. Again, that's the formula I use to find the length of a shorter side. Note there's a plus when you're finding the longest side and a minus when you're finding a shorter side. Let's look at a couple of examples. So firstly, let's say I have length here 15, length here 8. What would be the length of the hypotenuse? So I just use this formula here to find the longest side. So C would just be the square root of 8 squared plus 15 squared. Put it on your calculator and you get 17. So C will be 17 units. Obviously, if this was centimeters and centimeters, then C would be 17 centimeters. So let's look at an example now where we're finding one of the shorter sides. So let's say I tell you that the hypotenuse here is 17 and a shorter side's 10, and we'll find the length of the other side. Doesn't matter whether I call it X, A, whatever, I can still use the same formula. X equals the square root of longest side squared minus the shorter side. Now make sure that you always put the longest side first. If you try to do the square root of 10 squared minus 17 squared, you'll get an error because your calculator, or anyone for that matter, can't square root a negative. They just don't exist. So if I put that on my calculator, I get an irrational number, and to two decimal places, it's about 13.75. So just make sure you read the task sheet and determine whether it says, does it want it to the nearest whole number or does it want it to two decimal places or whatever. Now, we had an example in the third one where the answer was irrational, but in the first one, all numbers were whole numbers. If that happens, we call it a Pythagorean triad or a Pythagorean triple. So, a Pythagorean triple is three numbers, A, B, and C, such that A squared plus B squared equals C squared. So it's three whole numbers that could be the lengths of a right-angled triangle. So I just gave an example of a Pythagorean triple, 8, 15, and 17. Because 8 squared plus 15 squared equals 17 squared, this is a Pythagorean triple. Another Pythagorean triple, very simple, 3, 4, 5. Because 3 squared plus 4 squared equals 5 squared. Another one is 9, 40, and 41. Because 9 squared plus 40 squared equals 41 squared. So they both equal 1,681 if you were to put them on your calculator. If you do 9 squared plus 40 squared, you get 1681. If you do 41 squared, you get 1681. Something like 369, 3 squared, which is 9, plus 6 squared, which is 36, does not equal 9 squared. So this is not a Pythagorean triple, because those three whole numbers do not satisfy the rule A squared plus B squared equals C squared. So just make sure you know what a Pythagorean triple is. And they can be used to determine if a triangle is right-angled. So a triangle is right-angled if and only if the lengths of its sides form a Pythagorean triple. So for example, if I have this triangle here. It might look to you like it's right angled, but we're not going to just guess just from looking at it. So let's say I told you that we had 12, 15, and 18 were the lengths of the sides. So is this a right angled triangle? All we have to do is see whether 12, 15, and 18 form a Pythagorean triple. Now, if you put them on your calculator, 12 squared plus 15 squared gives you 389. 18 squared is 324. So we can see that this is not a Pythagorean triple. 12 squared plus 15 squared does not equal 18 squared, so no. This is not a right-angled triangle. So that's the converse of Pythagoras' theorem. So now I'm going to go through trigonometry. Please pause and copy down if you need any of this. The trigonometry kind of complements Pythagoras' theorem. So we're still looking at right-angled triangles. So we know that we can use Pythagoras' theorem to find sides, but I need to know the lengths of the other two sides. In trigonometry, I can find another side if I have one angle other than the right angle and one other side. I can also use trigonometry to find angles, which I couldn't do with Pythagoras. And if I want to find an angle using trigonometry, I need the lengths of two sides. So in order to do this, we need to know about the ratios. So before that, we need to label the sides properly. So if I call this angle here theta, so that's my reference angle. We already know how to label the hypotenuse. I told you on the previous slide, it's always the longer side, always facing the right angle. But we need to now label the other two sides, the two shorter sides. So the shorter side that's facing the angle is called the opposite side, and the shorter side next to the angle is called the adjacent. Now, it depends on the reference angle that you're being given. If I drew another right-angled triangle here, and this time I labeled the angle here alpha, the hypotenuse is the same. It doesn't change, always facing the right angle. But now this side would be opposite angle alpha, and this side would be adjacent because it's next to. So make sure that you can label the sides correctly. Now, it turns out that if the angle, either theta or alpha in the example I gave, if that's fixed, if I tell you it's like 30 degrees or something, then so too is the ratio of the sides. So there are three different ratios that we're interested in. So the first is called the sine ratio. It's abbreviated sin on your calculator. The cos ratio and the tangent ratio, abbreviated tan. So the sine ratio is the ratio of the opposite side to the hypotenuse. Cos is adjacent over hypotenuse, and tan opposite over adjacent. So the way I usually remember this is SOHCAHTOA. It's really important that you remember this. So this tells you when to use each one. So this is sine. That's what the S stands for. You use when you have opposite and hypotenuse. It's opposite over hypotenuse. Because opposite is written first, I know it goes on top of the fraction. So then the ca part, C for cos, adjacent over hypotenuse, and tan is opposite over adjacent. Okay? So when I say the ratios are fixed, I mean that if I tell you that theta is, say, 30, if I put on my calculator sine 30, I get a half. So that means that the ratio of the opposite side to the hypotenuse is a half. So if this angle here were 30 degrees, the opposite would be half as long as the hypotenuse. If the opposite side was 5, the hypotenuse would be 10. If the hypotenuse was 20, the opposite side would be 10. Okay? So it's really important you know that. That's what I mean about them being fixed. They have a specific value. Sine, cos, and tan, they're not numbers by themselves, they're functions. They need an input, they need an angle to go with them before they have any meaning. So we use these ratios to find sides and angles. So I'll now show you how to find sides using this. Let's have a look at this triangle here. It's right angled. I've got one side, one angle other than the right angle, and I want to find another side which is x. So I'm going to use trigonometry to do this. I can't use Pythagoras because I don't know the lengths of two sides. So if I look at this angle 40, this side 8 is the opposite and x is the hypotenuse. So I go to my SOHCAHTOA. Which one involves opposite and hypotenuse? Well, that's sine. So this is how I set up the equation. Sine, remember it needs an angle to go with it, equals opposite over hypotenuse. Now, to solve this equation, if the side you want to find is on the bottom as it is here, you divide. So x is 8 divided by sine 40. You just put that on your calculator, but you must make sure your calculator is in degrees. So if I put that on my calculator, the answer I get is 12.45, just to 2 decimal places, okay? Note that I was finding the hypotenuse, the longest side, so the answer I get should be more than 8, so I know I've done something right. Let's look at another example. So we'll look at this triangle now. I'll say this angle is 18 degrees. And we have 12, and let's call that y. So I've got a right angle triangle, one side, one angle other than the right angle. I want to find another side. I use trigonometry. So this time I've got the adjacent side and the hypotenuse. So I'm going to use cos. So cos of angle equals, now make sure you get them the right way around. So cos is adjacent first and then hypotenuse. So the adjacent goes on top. So this time the thing I want to find is on top. So if the thing you want to find is on the bottom, I divide as in the previous example, but if it's on the top, I times. So here, y is 12, not divided by, but times cos 18. So again, you put that on your calculator. It's important that your calculator is in degrees mode, otherwise you might get the wrong answer. So if I put it on my calculator, I get about 11.4 to 1 decimal place, okay? And I know I've done something right because 12 is the hypotenuse. The answer I get should be less than 12, and it is. So that's how you find a side. Let's have a quick look at finding angles. So let's look at an example where we're finding an angle. Remember I said on the previous slide, to find an angle using trigonometry, you need the lengths of two sides. So let's say I have a triangle here, and I know I have two sides, 10 and 12, and I want to find this angle here, okay? So the ratios are still the same. We're going to use one of the ratios, sine, cos, or tan, but when we're finding an angle, we use inverse, sine inverse, cos inverse, or tan inverse. So we can skip straight to the inverse part. We have theta equals the sine inverse of opposite over hypotenuse. So use that when you're given the opposite and the hypotenuse. And you use, of course, cos inverse if you're told the adjacent and the hypotenuse. To find an angle using tan, you need to be given the opposite and adjacent. And that's exactly what we're given here. This side is the opposite, this side is the adjacent. So I can skip straight to the answer. Theta, the angle I'm looking for, is just going to be tan inverse of opposite over adjacent. It's really important you understand. We don't use tan on our calculator, we use tan inverse. And if I put that on my calculator, I get about 40 degrees, and that is to the nearest degree, okay? So finding other angles is, pretty much the same. You just use that formula. Just make sure you get these right. So for example, in sine, it's opposite over hypotenuse, not the other way around. Because if you get it the other way around, you might get an error. So we know that the sine ratio can't be more than 1 because the opposite always has to be less than the hypotenuse. Same for cos. The cos ratio can't be more than 1 because the adjacent can't equal or be more than the hypotenuse. So if you tried to take the sine inverse or the cos inverse of a number greater than 1, you would get an error. Doesn't happen with tan. The opposite can be longer or shorter than the adjacent. But it does happen with sine and cos. So make sure you get them the right way around, otherwise you might get an error when you're finding angles. So this is all you need to know. The project will cover more in-depth kind of stuff than this, but this is just basic to help you revise. So try some more reasoning and problem-solving questions if you want to prepare yourself best for the task. There won't be any applications of trigonometry like angles of elevation or depression. If you know what's in this video, you're giving yourself a very good head start. Just make sure you practice on problem solving and reasoning questions to extend your knowledge. Hope you've enjoyed this video. Sorry it's been a bit long. This has been the luckiest maths teacher ever. Have a great day.